Most engineers only focus on lateral seismic load. But here is the critical mistake. See, ignoring torsion can lead to catastrophic failures, especially during the earthquakes. So how do you account for the twisting actions in buildings? So let's break it down step by step. See, every building under seismic loading doesn't just sway side to side, but it also twists, especially when the center of mass and center of resistance are not aligned. So this twist generates torsional moments, and if not accounted for, the building could experience unexpected damage during the earthquake. See, most beginners engineers think, okay, I applied the seismic loads, I am done. But are you capturing the torsional effects? See, IS 1893-2016 clearly states that you must consider both natural torsional and accidental eccentricity in the seismic design. Miss this and you are ignoring the forces that could bring the structure down. So let's understand the solution. So let's go to the code. See, clause 7.8.2 gives the design eccentricity. You can check out the following equation. See, it is the greater of these two equations. Now here in this particular equation, you have this parameter SE, which is known as static eccentricity. Basically, it is between the center of mass and center of resistance. Another parameter is the floor plan dimension, which is perpendicular to the direction of the force. 1.5 is the dynamic amplification factor, and this 0.05b is the accidental eccentricity. See, this ensures you are not underestimating the torsional effect. See, for the older version, I have already created one detailed video where I have manually verified all these calculations. You can check out that particular link in the description box, where I have matched all the result for the seismic static analysis and accidental load as well. So for the latest version, now let's translate this into STAAD.Pro's latest version with rigid diaphragm. See, there are two key parameters in the latest STAAD.Pro Connect Edition version. See, DEC, which stands for Dynamic Eccentricity Coefficient. DEC stands for 1.5. See, here DEC is 1.5 when ECC is positive, and DEC is 1 when ECC is negative. See, basically ECC stands for Accidental Eccentricity Coefficient, which is plus 0.05 or minus 0.05. Alright, so let's understand how you can write this syntax in STAAD editor. So here is the typical load case setup I am showing you over here. Let's say your load 6 is the seismic in H direction for the response spectrum case, and here is the text definition you can check out for the X direction. Now in the same manner you can create for X and Z direction similar way. So here you can use this text editor in your STAAD editor syntax for both the direction. You can repeat this same load case pattern for the Z direction seismic load as well. So here if you observe, no torsion is considered in Y direction. One important point, no torsion is considered in the Y direction. Now you might be thinking, what about the multiple earthquakes? See, you have seen cases like Turkey's 2023's earthquakes, right? So should we design for the multiple consecutive earthquakes? See, as per ASCE 7, the answer is no. See, it doesn't require design for multiple earthquakes because aftershocks are usually smaller by 1 magnitude. Buildings are inspected after major events, and the possibility of the larger aftershocks after a maximum considered earthquake is less than 0.00005 per year. So that's too rare to be practical for design purposes. So here is my conclusion. First point, never skip torsional effects, especially in the irregular or asymmetrical buildings. Another point, use this DEC and ECC in the latest version properly in the STAAD.Pro to capture both natural and accidental eccentricity. While ASCE doesn't mandate multiple quake design, your engineering judgment should be always site sensitive. Would you have modeled torsion differently? Comment below. Save this video for your next STAAD project, and don't forget to subscribe for more real-world seismic design tips. I'll see you in the next video, and always remember, don't just learn software, learn concepts. Thank you.